All right, so today is Tuesday, December 3rd, 12/3, 2019. We're on system of equations today using substitution. So the objective, pretty easy, Emma.
Solve a system of equations using substitution.
There it is. So there's one tool that we've learned so far. Today is learning our second tool. Does anyone remember how would I solve a system of linear equations? And this is, I know it's like review from before we took Thanksgiving break. There's one tool that I've showed you so far. Kira? Graphing, there it is. And that requires that you're really good at Unit 4. You know how to graph standard form. You know how to graph slope-intercept form. Not necessarily point-slope form, because we don't really use that until we need to do more hardcore graphing. And then today's the second one, which is substitution. If you want to be cool, you don't have to do this. You can say, well, in the future, we're also going to do 3 as well, which is going to be elimination, but you don't have to worry about that for now. Tomorrow and Thursday, so the next 2 days, I'm going to be teaching you how to do elimination, because it's one of the more tricky ones. All right, but the general goal for both substitution and elimination, for both of these two, is always the same goal. You need to get an equation with how many variables? Wyatt?
What?
1, yeah. With 1 variable. And then you'll solve. Because the whole problem is, and you'll see this even if you study math and you go to college, be careful. If you go to college and you study math, they still have the same goal in mind. If you're doing like these multivariable calculus or doing something really hard with linear algebra, the whole idea is make it linear, make it 1 variable. You can always solve for 1 variable. There's a bunch of tricks you'll eventually learn, especially for this class too. What are the tricks to get it so that you can just have 1 variable and then solve it just like we did all the way back in Unit 1. Like if I have x plus 2 is equal to 5, I'll subtract 2 on both sides, you've solved it if you have just 1 variable. All right, so here's the general procedure. We're going to isolate, and we'll say for a variable. We'll plug in that variable into the other equation. So plug in to other equation. And then you'll do the solving. So that was the whole goal, right? If I come back here to our original goal, we wanted to solve. Now we can solve because isolating and plug in will get it so I get an equation with 1 variable. And then now I can solve. And then we'll solve for like either x or y, but you need to have both x and y, so plug into either equation. I'll write this on here because it's nice to know now. Plug in to either, and I'll underline that. It doesn't matter which equation, to either equation. Both equations will work, and then you'll solve for the other variable. So, let's try it out. So I'll leave the procedure up here so we can still reference it. Here is my system of linear equations. And I always use the word linear, meaning these are just lines. I'm not going to give you one's a U shape and one's a line. No, they're both lines. Eventually we'll do U shapes later, curves and stuff, so we'll get harder. But I have 2 lines. I could graph them, but the graph might not be quite accurate. Like what if I get 1 2/3? How do I know it's 1 2/3 and not 1 5/9? It's hard, right? So I need to isolate for a variable. We'll check this out. That variable x, it's isolated. It is by itself. We can say, yeah, step 1, check. We've already done it. It's already isolated for us. So we've done step 1. Well, it's been done for us. And now we're going to do step 2. We're going to plug in this x into this x. This 5x, this x right here is no longer x. This x turns into 2y minus 6. I'm going to write it out. Here we go. So a way that you can write this in your notes is you can circle the 2y minus 6. You can draw an arrow to this x up here. You're saying, hey, this x is going to be turned into 2y minus 6. They are the same thing. And I can rewrite that down here. This is now going to be 5 and keep parentheses. Whenever you do substitution, keep your parentheses. 5 times the quantity of 2y minus 6 and your parentheses. And then you have to fill in the rest of the equation. So this really is 5x And then I'm going to keep writing down the minus 2y equals 10. So I keep writing down minus 2y is equal to 10.
So if we were to isolate the top one and did it the other way around?
It would still work, yep. It doesn't matter which variable you isolate for. What if I added 2y and then divide both sides by 5 to isolate that x, or isolated that y, or isolated this y? It doesn't matter which variable you isolate for. You just need to substitute it. If you substitute, you will get rid of a variable. You will achieve this goal of getting an equation with one variable. It doesn't matter how you do substitution. If you do it once, you've probably gotten rid of the variables. All right, so now we have to do step 3, which is kind of the tricky part. You need to solve this now. So this is where I'm going to need some quiet raised hands. You should know how to do this now. I have this equation. I need to somehow do something with this 5. Who still has their cards? Kira?
You have to distribute the 5.
All right, so tell me what to write then.
So it would be 5 times 2y equals 10y minus 30 in the parentheses.
Yep, and then I'm going to keep writing what's over here, right? Minus 2y is equal to 10. Yeah, perfect. Thank you. I'll take your card. All right. So again, we're simplifying, so we're going down with PEMDAS. We deal with the parentheses, which is really multiplication. So we multiplied, and now we have to deal with addition and subtraction. Is there anything that we can add or subtract on the left-hand side with a quiet raised hand? Anyone with their card? Yes.
Add 30 to 10.
Ooh, careful. So those aren't like terms. Like terms have the same variable. So try again. You got this, Ulysses.
I think you got like 30 to 10 on the right side.
Okay, so that is eventually what we're going to do. I guess it's not incorrect. So you're saying add 30 to both sides like that?
Yeah.
Okay, that's actually, oh, it's correct. I was thinking more of trying to simplify this left-hand side, but yeah, we can go ahead and do this now if you want, and we can simplify the next step. So read me what I have after that, Ulysses, after you add 30 to both sides.
It'd be 10y minus 2y equals 40.
Perfect, yeah, thank you. Sorry, I totally misunderstood what you're saying. Thank you, Charles, for helping me out. Yeah, that's a perfect step. And next, what am I going to do? Who has their card? Larissa, yeah.
You would just subtract
Yeah, so what am I going to have on the left-hand side?
8y.
There it is. 8y is equal to 40. Thank you. And final step to get y by itself. Who has their card? Jade.
Divide both sides by 8.
Divide both sides by 8. Divide both sides by 8. And there it is. Y is equal to 5. We can box it. That is half of the answer.
We still need to find x?
Yes, so I always want you to find the comparisons. What did we do with graphing? What did we do with substitution? And connect that to elimination too. When we graphed this, what we really had, and I can do this on here, I keep wanting to come up here and write. What we had was two lines that intersected. Our solution was a point, right, when we graphed it? This point had an x and a y coordinate. We have just found the x coordinate. We still need to find the y coordinate of wherever that intersection happened.
Couldn't we find the y coordinate?
Oh, sorry. We just found the y coordinate. Yeah, Charles and Wyatt, you can give yourselves the point. Teacher error. Yeah, Larissa.
So, what is it called when we put the whole thing into the x?
The whole thing into the, substitute?
Yeah. Oh, yeah. So, like, when you were trying to find y, would you when you're trying to find x, would you substitute for y?
You could do that, yeah, exactly. And there's an even easier way now that we have y. Since we know that y is 5, we can plug in this y equal to 5 into this y or this y, because we know both of those y's are 5 for the solution. Okay, so this is where I get to ask you the fun question. There's no wrong answer. Which of these y's do you want to substitute into? Which one looks easier to you? Who has their card still? Who's over there? Jade, I thought you turned in your card. Okay, yeah, go for it, Jade.
Oh yeah, I just answered 8 divided.
Okay, never mind. Who still has their card?
I have a pencil.
You do have a pencil indeed.
I have an eraser.
Yeah, Asha, which one did you want to plug into?
The bottom one, I guess.
Bottom one. Okay, read it out to me. So you're going to read out the x because that hasn't been substituted out. So I have
X equals 2 times 5 minus 6.
perfect. Yeah, thank you. I'll take your card. And I need one final volunteer to tell me how do I simplify all the x stuff. Is there anyone that still has their card? No, we'll go with Charles.
You would do 2 times 5 equals 10 minus 6 equals 4, so x equals 4.
Perfect. There it is. So you can write your answer. Oh yeah, question, Kira.
I don't really understand why you got like 5.
Yeah. So does anyone else want to try to explain where the 5 came from, Asha?
So the y equals 5, what we solved down there, is telling us what 2y
Oh.
is.
Yeah.
So we can automatically just plug 5 into y.
What?
Can I say why it was easier to put it into the bottom equation?
Yes, go for it.
Okay, I'm saying I think it's easier to put it into the bottom equation because x is already isolated, and if it's just saying x is equal to this, you just plug in 5. You don't have any more variables on the right side, so you're just trying to solve at that point, just for x. So I think it's easier that way.
Yeah. So if we had plugged it up here, y equals 5, then we would have had to add this over to this side. Then we would have had to divide by 5. This one you just plugged in, you're done, basically.
Yeah.
All right, so there's 2 ways to write your answer. You can write your answer just boxing your y and boxing your x, or you can do it like we did with graphing, which is to label your x and y coordinate together. So another way of answering this is 4, 5 is your final answer. It always goes x then y. So if you forgot that, x then y. Yeah, I don't know. All right, we have one more example on the back. I want to see if you guys can do it because it's basically the same thing. I've isolated the variable for you. Sometimes that might not happen. I don't have an example 3 on here, do I? No. So you guys try example 2 on your own. Good luck. For example number 2, you need to make sure that you plug in this y and this y are the same y, so that this 2x plus 14 is plugged into this variable. So our new equation is, I'm rewriting this now, 3x plus 4 times the quantity of 2x plus 14, and still writing the equals 12 equals 12. All right, and then I need to distribute this 4 into both of these terms, so it's going to be 3x plus 4 times 2x is 8x, and 4 times 14 is 56. And that's equal to 12 still. I can combine 8x and 3x to be 11x. Plus 56 is equal to 12. Let's subtract 56 on both sides. I should be switching colors to make this stand out a little bit better. Minus 56 on both sides.
Yeah.
My average is 32.
What's your
And now 11x is equal to, this is going to be a negative 44. Let's divide both sides by 11, divide by 11, divide by 11, and those cancel out. I'm left with x is equal to negative 4. So that's half of the answer. The next half of the answer, I can plug in this negative 4 into either this x or this x. I'll get the same answer either way. I think that this bottom x is easier, so I'm going to say y is equal to 2 times this negative 4 down here. Negative 4. That's going to be still adding 14. So I've rewritten the equation correctly. Now this is y is equal to negative 8 plus 14, which means y is equal to, that's going to be 6. So our final answer is negative 4, 6.